Hello, my name is Keshwani. 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 We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, the GMAT Official Guide 2022. If you do not own this book already, purchase one immediately. You're going to need it. Always make sure the book is in front of you when you're doing the work with me so that you can follow the work. Today we'll solve some problem that you'll find on page number 115. Please turn to it. Page 115, the very first problem that you see there is number 20. In number 20 we are told that in 2000, from 2000 to 2003 in a firm, the number of employees went up by a quarter. Then from 2003 to 2006 we are told the number of employees went down by a third. We are also told that in 2006 they had exactly 100 employees. The question is, how many people did they have in 2000? What we need to understand here is that because of the fact that the figure is first going up by a quarter and going down by a third, whatever that figure is, has to be a multiple of 12. It has to be divisible by 4 and 3. It has to be a multiple of 12. What does it tell us? It tells us that any answer choice that is not a multiple of 12 cannot possibly work here. For example, 200 is not going to work, 100 is not going to work, but that is 60. 75 is not going to work. It's either 120 or 60. Let's try 120. If we try 120, let's put down here 2000, 2003, and 2006, and let's see if it works. If you start out with 120 in 2000, we are told that it goes up by a quarter. Half of 120 is 60, quarter will be 30, so it goes up by a third, goes up by a quarter, goes up by a 30, it becomes 150. Then we are further told that it goes down by a third. A third of 150 is 50. A third of 150 is 50, so it goes down by 50, leaving us with 100, exactly the way it's supposed to be. It matches, it works. The answer is B. That's all there is. Don't try to solve this problem algebraically, it will take forever. Next one, number 21. Number 21, it says that we have, it says which must be true about the mean and median of 5 numbers. 5, not just any old numbers obviously. I left out the most important part, 5 consecutive numbers. So let's just make up 5 consecutive numbers and we'll go by statement by statement. Just make up any 5 number, doesn't matter. 3, 4, 5. Let's erase all of this thing. Make up 5 consecutive numbers and then we'll look at these statements. 3, 4, 5, 6, and 7. 5 consecutive numbers. The first statement says that average is one of them. It says average is one of the numbers, which it is. Average of 5 consecutive numbers, any 5 consecutive numbers, the average is going to be the middle one because there are 5 of them. So that is true, average is one of them. The statement 2 says that the median is one of them. But the median is also 5 obviously. As a matter of fact, mean and medians are equal. So statement 2 is also true. And it turns out that statement number 3 says exactly what we just said, that is, that in this case the mean and the median obviously are going to be equal. The answer is statement 1, 2, and 3. They are all true. The answer is E. The answer is E. Number 22. In number 22, we are told that we have 16 coins. 16 coins made up of dimes and quarters. Dimes and quarters. And there are 16 of them. There you go, that's our first equation. Dimes plus quarter has to equal to 16. That's our first equation. Let's now put it in an awkward position like this. Let's put it here. So the number of dimes plus the number of quarter has to be 16. We are further told that the value is 235. The value of this 16 coins is 235. Which means that since dimes represent 10 cents, 10 times d, or better yet, let's write it in a proper way, 10d plus the 25q. 25 times q represents the value of the quarters. If you add up these two values, you get 235. There we go. We have two very simple equations. The question simply is, how many quarters do we have? We just have to solve for it. Very simple, very straightforward. Two simple linear equations. Let's multiply this equation by 10. If we multiply this equation by 10, we end up with 10d. Let's put it here. 10d plus 10q has to equal 160. There you go. Let's subtract one equation from the other. 10d is going to drop out, which was the whole point. 25q minus 10q is going to give us 15q. And here we get 5. 5 minus 0 is 5. And 13 minus 6. 13 minus 6 is going to be 7. And that's it, because we had to borrow one from here. There you go. Divide both sides by 15. And it turns out that there are 5 quarters. There are 5 quarters. If that in fact is true, if there are 5 quarters, they represent $1.25. And if there are 5 quarters, we must have 11 dimes. And if we have 11 dimes, they represent $1.10. And as long as it adds up to 235, we are done, which it does. Number 23. Number 23. In 23, we are told that we bought for $2.80 per dozen. Whatever it is that we're buying makes no difference. Makes absolutely no difference. You can buy eggs or you can buy donuts. It makes no difference. We're going to sell it. We sold 3, 4, 90 cents. And we did that five dozens. We did that 5 dozens. We are selling eggs. We sold 5 dozen eggs. We bought them for $2.80 for a dozen. $2.80 for a dozen, which means the amount of money that we spent is $2.80 times 5, $2.80 times 10. $2.80 times 10 would have been exactly $28. So this is $14. That's what we paid for them. Let's see what we got from them. We sold 3 for 90 cents, which means we must have sold one for 30 cents. We're not selling one, we're selling 5 dozens. There are 60 of them. So times 60. There you go. $18 exactly. We bought them for $14 and we sold them for $18. We made a grand profit of $4. Number 24. Number 24, we have cards. Cards are numbered 1 through 24. Each card has a unique number. We're going to draw one at random. And now the question is, what are the odds? What are the odds? What's the probability? What's the probability the card that we're going to choose? The card that we're going to choose is divisible by both 2 and 3 or divisible by 7. So again, 24 cards we are holding. Each card is numbered 1 through 24. Each has a unique number. We're going to draw one card at random. What are the odds that the number on that card is either something that is divisible by 2 or 2 and 3? 2 and 3. Well, if it's divisible by both 2 and 3, that's a roundabout way of saying that the number has to be a multiple of 6. A number has to be a multiple of 6 if it's divisible by both 2 and 3. Which means we can have a 6, we can have 12, we can have 18, we can have any multiple of 6 as long as it goes up to 24. I mean to say or or a number that is divisible by 7, which means you can have 7, 14, and 21. That's all there is. 1, 2, 3, 4, 5, 6, 7. There are 7 out of 24. The odds of picking such a number is 7 out of 24. Number 25. In number 25, we are told that the circumference of a circle inscribed in a square is 25 pi. The question simply is, what's the perimeter of such a square? What's the perimeter of such a square? So let's draw it. We're going to inscribe a circle inside a square. And we want to find out the perimeter of this square. Circumference, make sure you pay attention. We are given circumference, not the area. Circumference, as we know, is 2 pi r. 2 pi r, and we are told this is equal to 25 pi. Divide both sides by pi, pi drops out, and 2 times r is 25. But 2 times r is the radius right here. 2 times r right here, from here to here, and then from here to here. Well, that's the radius, which is also the diameter of the circle, which is each side, each side of the circle. There you go. Therefore, the perimeter must be, therefore the perimeter that we're looking for is simply 25 times 4. It's simply 25 times 4. Number 26. Number 26. I don't know why I left that thing. Number 26, we are told that 1 is less than x, which is less than y, which is less than z, and the question is which has the greatest value among the 5. Z times x plus 1, z times y plus 1, x times y plus z, y times x plus z, or z times x plus y. Let's begin, shall we? A, B, C, D, and E. There are 2 ways you can go about it. One way is to simply plug in numbers. Just plug in any number. For example, you can plug in 2, you can plug in 2, 3, and 4, and work through all of these 5 quantities and find out which one is the greatest quantity. Of course, you can most certainly do that. We're going to do something different. Let's see what we can do here. Here we have z times x plus 1, and here we have z times y plus 1. Well, obviously x plus 1 has to be less than y plus 1 because x is more than y, which means quantity in A is less than quantity in B. If quantity in A is less than quantity in B, A cannot possibly be the greatest quantity. Similarly, here we have z times y plus 1, and here we have z times y plus x. X is more than 1. Since x is more than 1, x plus y is more than y plus 1. Therefore, B cannot possibly be it. Answer is either C, D, or E. Now we have to do a little bit more work. Let's start with C. C says x, and D says, okay, let's get going. So we have x times y plus x times z, and here we have x times y and y times. There you go. X and y drop out. X times z versus y times z, we can divide both sides by z, and we can do that because these are all positive numbers, so it doesn't affect inequality. Whichever side the inequality is pointing, greater than or less than, it's not going to be affected if we divide something because they're both all positive. There you go. We're comparing x versus y, and y is greater. Where was this one? That was D, which means C cannot be the answer. Now we go one more round and compare D versus E. That's all. Let's compare D versus E. So that's D. So here we have x times y plus y times z, and in E we have z times x plus y. We're almost there. It has to be one or the other, obviously. So here we give x times z plus y times z. Is there anything common? There you go. Of course there's something common right there. That plays no role. Divide both of this quantity by x. There you go. And of course z is bigger than y. Z is bigger than y. Z is right here. The answer is E. The answer is E. Number 27. Number 27. Let's see what we have in 27. Oh, by the way, we are on the next page now, page number 116. Obviously you know it, or we are not. 20, oh yes we are, 27. On 27 we are told that we have a set, two sets actually. Set X, which is made up of consecutive numbers, 8 consecutive numbers. It is made up of 8 consecutive numbers, so we're going to make up 8 consecutive numbers. 1, 2, 3, all the way up to 8. This is our set X. They didn't give it to us, we just make it up. Just make up any 8 consecutive numbers, or just do 1, 2, 3, 4. Don't try to be fancy. Set Y says that we're going to make up a set where we're going to add 4 to each and subtract 4 from each of these numbers. When we have a new set Y, the question simply is how many more members set Y has compared to set X. So let's find out. So we're going to add 4 to this thing. If you start from here, we're going to end up with 1 plus 4 is 5, so we can end up with, so here we have set X, 1, 2, 3, 4, 5, 6, and 7, and 8. We're going to start adding 4, so we can end up with 5, or rather 5, 6, 7, 8, and then that will bring us up to 4, then 4 plus 5 is 9, 10, 11, and 12. Of course it's going to go up to 12 because 8 plus 4 is 12. Now let's subtract 4. If you start subtracting 4 from here, we end up with 4, 3, 2, 1, and then that's going to bring us to 5. 5 minus 4 is 1, then 4 minus 4 is 0, negative 1, negative 2, and negative 3. There is too much talk for nothing at all. There are 4 here, there are 4 here. This is the same. This part is the same. Set Y has 8 more members compared to set X. Set Y has 8 more members compared to set X. Number 28. Number 28. I always pause for a second in case I was obstructing your view of the blackboard, so I give you 2 seconds so that you have unobstructed view, and you can pause the video if you have to, so that you can see it properly. Number 28. 28 is a very silly question. I don't know who wrote this question, but in my opinion that person doesn't belong at the GMAT. It's too simple, too silly. They're asking us how much this thing is approximately. It is approximately 60.2 is approximately 60. It is 1.03 times 5 is approximately 1 times 5. It is 12. The quantity that is given to us is approximately equal to 12. Number 29 on the other hand is an entirely different ballgame. At number 29 we're going to have to do some thinking, which is why it's important that you have the book in front of you. Pause the video right now if you have to, read the problem. You may have to reread it, understand the problem. Here I just simply give you the gist of it, just the nub of it. NUB. We are told that we have 140 books. And we are told that we have 3 kinds of books. We have books that are paperback fiction, or we have paperback non-fiction, books that are non-fiction paperback, or we have hardcover non-fiction. Hardcover non-fiction. There you go. That's the first thing we are told. We are further told that this guy owns 20 more paperback non-fiction than hardcover non-fiction. We are also told that he owns twice as many hardcover non-fiction he owns twice as many paperback fiction as paperback non-fiction. I lost track of where I was reading. There we go. That is what is given to us. The question simply is this quantity. How many does he have? How many hardcover non-fiction does he have? That's what we're interested in. That's the unknown we're looking for. It's a very straightforward deal. Is because we have three very simple equations and three unknowns, three independent equations, three unknowns. Of course, we can find out any one of these three values. We're simply looking for hardcover non-fiction. Let's find out. What is our first equation? The first equation is right here. We have 140 books, which means paperback non-fiction plus paperback fiction plus paperback non-fiction plus hardcover non-fiction has to equal 140. That's our first equation. Second, which is right here, which says that he owns 20 more paperback non-fiction. Paperback non-fiction has to equal to how many hardcover non-fiction he has plus 20 more. That's our second equation. We're further told that he owns twice as many paperback non-fiction. Paperback non-fiction that he has is 2 times as many number of books that he has that are paperback non-fiction. Number of paperback fiction that he owns twice as many paperback fiction as non-fiction. There we go. Let's see what we can do. I left no room at all for myself. I'm going to do here. That was very silly of me. So let's begin. 140 has to equal paperback fiction plus paperback non-fiction plus hardcover non-fiction. Paperback non-fiction we know is paperback non-fiction, which is this guy, which is simply hardcover non-fiction plus 20, so that's this guy. Paperback fiction we know is 2 times paperback non-fiction. We're going to continue here and we're going to make the substitution one more time. Paperback non-fiction we know is this quantity. We're going to substitute this quantity here for here, and we end up with 2 times hardcover non-fiction plus 20 plus this quantity plus this quantity, and all of that has to equal 140. I'm going to erase this in a second, but let's just finish it. So here we get 2 times hardcovers non-fiction, 3 times and 4 times hardcover non-fiction, and then 2 times 20 is 40 plus a 20, that's 60, has to equal 140. There we go. Subtract 60 from both sides and we end up with 80. 4 times, there we go, 4 goes into this, and the answer is 20. He must have 20 hardcover non-fiction. Number 30. Number 30. Number 30 is a very straightforward question. We simply want to find the average of 3, 15, 32 and n plus 1. We don't want to find it rather. We are told that the average is 81. And the question is, how much is n? Based on the fact that the average of these 4 quantities, 3, 15, 32 and n plus 1 is 81, how much is n? Let's find out, shall we? So we have 3 plus 15 plus 32 plus n plus 1. And since their average is 81, the sum of these 4 has to equal to 81 times 4. Here we go. 3 plus 15. 3 plus 15 is 18. We have 18 on this side. This should be 18, not 81. I miswrote it. It's 18. Okay, so we have 18 on this side, 18 on this side, we have 4 18s here, we have 1 18 here. Let's subtract 18 from both sides. If we subtract 18 from both sides of the equation, now we have only 3 18s. There we go. 32 plus 1 is 33, so 33 plus n has to equal 3 times 18. Bring 33 to that side, so n would equal 3 times 18 minus, typically I don't write it like this, typically I like to line up my equations. I'm trying to save room here. So let's bring 33 to this side, so we have n is equal to 3 times 18 minus 33, which is same as 3 times 18 minus 11. 18 minus 11 is 7. There you go. The number that we're looking for is 21. Number that we're looking for is 21. Number 31. In number 31, we are told that we have A, B, and C that are on a straight line. A, B, and C are on a straight line. So let's put them on a straight line. A, B, C, we are told that they are on a straight line. We're going to develop the picture as we read one line at a time. Then we are told that S is halfway between A and B. S. The school is exactly halfway between this guy's house and this guy's house. Further on, we are told that B is halfway between S and C. B is halfway between S and C. Let's put in numbers here. Let's make it 5 and 5, so that we understand that this is halfway. We are told now that in the next sentence we are told that B is halfway between S and C. If S to B is 5, B to C must also be 5. The picture does not need to be drawn to scale. You understand? The picture does not need to be drawn to scale because we're not babies. We understand that this is 5 and this is 5, which means that B is exactly halfway between S and C. Let's read the next part. We don't need it anymore. Let's read the juicy bit, the punchline. There we go. We are told that S is 4 miles away from C. S is 4 miles away from C. So we were wrong. If S to C is 4, then we were wrong. We have 10 here. We have 5 and 5. It's not 5 and 5. S is 4 miles from C. We need to change these numbers to 2. There we go. And now the question simply is, how much is A to C? Well, A to C would be 6, 2, 2, and 2. Number 32. Number 32. In number 32, we're given a picture that looks something like this. I did not do a very good job of making it, but that's okay. There we go, that will be better. It looks something like this. The picture looks something like this. We are told that this angle is 150. This angle right here is 150. We are told that this angle is 150. We are told that this angle is 150. And what we want to find out is this angle right here, X. Let's find out, shall we? I'm going to change the color. Hopefully you'll be able to tell the difference. This is a red color. I'm going to change the color so that we can tell the difference between what is given to us and what we're going to introduce ourselves. Let's begin. It's very straightforward actually. If this angle is 150 from here to here and this is a straight line, if this is a straight line and this is 150, this would have to be 30. Similarly, if that is 150, this would have to be 30. If this is 30 and this is 30, since the sum of the angles in any triangle is 180, this guy must be 120. If this guy is 120, the remaining angle here has to be 60. You see how we are progressing? Similarly, if this is 150, this would have to be 30. So if this is 30 and this is 60, 30 plus 60 is 90, and since the sum of the angles in any triangle has to be 180, as we just said, this guy, the remaining guy, X, would have to be 90 degrees. Would have to be 90 degrees. Number 33. Number 33 says that we are going at the speed of 1 mile per minute. 1 mile per minute is a very annoying way of saying that we are going 60 miles per hour. We are told that we are burning gas at the rate of 5 gallons every 2 hours. It is not 5 gallons per hour, it's 5 gallons every 2 hours. We are also told that we burned a total of 3 3/4 gallons. The question simply is, how far did we drive? How far did we drive? I don't know why I had the uncontrollable urge to put D, the capital letter. We no longer need this thing. But before we can worry about how far we can drive, we have to first establish how long we have been driving. How long we have been driving will come from these two pieces of information right here. The fact that we're burning 5 gallons every 2 hours and the fact that we burned 3 3/4 gallon, that will tell us how many hours we've been driving. Let's find out, shall we? So we're going to set it up as a proportion problem, gallons and hours. Gallons and hours. And we are told that we're burning 5 gallons every 2 hours. 5 gallons every 2 hours. And we are told that we have burned 3 3/4 gallons. 3 3/4 gallons. Question is, if that's the case, how many hours did we drive? Let's call it, instead of calling it X, let's call it H for the hours. There we go. Let's solve for it, shall we? So H would have to equal to 2 times 3 3/4 over 5. There we go. That's pretty straightforward. 2 times 3 is 6. And 2 times 3/4, if I have 3/4 times 2, I will have 6/4 over 5. Let's pick up this thing. Let's pick up this guy from here, because we're running out of room. Maybe you can finish this thing. Maybe you can finish it here. 6/4 is 1 1/2, isn't it? 6/4 is 1 1/2. 1 1/2 plus 6 is 7 1/2. 7 1/2 over 5. Let's multiply top and bottom by 2. We are almost there. We multiply top and bottom by 2 so that we can get a nice 10 at the bottom. 7 1/2 times 2 is 15. 15 over 10 looks like, there we go. Looks like we've been driving for an hour and a half. Or if you like, 90 minutes. 90. Jesus. 90 minutes. Well, if we've been driving for 90 minutes and we were told in the beginning that we're driving at 1 mile per minute, well, there you go. We must have driven 90 miles. That's all. That's the end of that page. That's a good place to stop. We'll pick up from here when we meet next time tomorrow. In the meantime, if you would like to work with me, if you would like to hire me, if you would like to hire my services to help you get ready for the exam, for the GMAT, math portion that is, you can get hold of me by sending me an email. Just go to my website at keshwaniprep.com. keshwaniprep.com. From there you can either send me an email or fill out the form, or we'll talk some more. Alright? I'll see you tomorrow. Bye now.